Now we are going to talk about lists in Python. Lists are one of the most common and powerful ways to store and organize data. Think of a list as a shopping basket. You can put items into it, take them out, change them, or check what's inside. In Python, lists let us do exactly that with numbers, words, or even other lists. So let's just start with creating a list. We create lists by putting values inside square brackets separated by commas. For example, a list of numbers such as 10, 20, 30, 40, and 50, or a list of fruits such as apple, plum because I like that, and let's say cherry. So let's run this. The first list, numbers, contains 5 integers. The second list, fruits, contains 3 strings. If I type print numbers, Python shows the items in the first list, 10, 20, 30, 40, and 50. And if I type print fruits, I get the list of items in the second list, in the fruits list. So a list is simply a collection of items grouped together. Since lists are ordered, we can access individual items by their index. For example, let me create the fruits list again. And access the items in the list. Fruits, or let's do print function. Fruits, index number 0, index number 2, and print. We can also do negative values. So let's run this. The first line gives us the first item, which is apple. The second line gives us the third item, which is cherry. And the third line is a neat trick. Negative indices count from the end. So this also gives us cherry. Remember, lists in Python always start at index 0, not 1. That's a common beginner mistake. One of the best features of lists is that they are mutable, which means we can change them. For example, let me do another code cell. And let's talk about changing or modifying lists. Index number 1, originally our list was apple, plum and cherry. After doing this change, the list changed to apple, blueberry and cherry. So now plum has been replaced with blueberry. Notice that you don't need to create a new list. You can just update an existing one. We often want to grow our lists. Python gives us two useful methods to do that. Adding items using append and insert. So let's, for example, fruits that append orange, parent fruits running this, the list becomes apple, blueberry, cherry, orange. So the previous list was apple, blueberry, cherry. We just add a new item at the end of the list. Now let's use insert. Fruits dot insert this puts mango at index 1. So the list is now apple, mango, blueberry, cherry and orange. We can also remove items from the list. Let's talk about removing items. There are three main ways to do that. For example, fruits remove apple. If I run this, now the list becomes mango, blueberry, cherry and orange, so we don't have the apple item or apple value in the list anymore. If I use pop, So the popped item is the last item, the orange item. The list is now mango, blueberry, and cherry. And if I want to remove by index, I can do that. This removes the first item. The list is now, so without the first item, which was mango, the list is now blueberry and cherry. So depending on whether you know the value, the index, or just want the last item, you can choose between these methods. There are also some other useful operations on lists. So Python gives us some quick built-in function to analyze lists. For example, we can get the length of the list, the minimum value within the list, the maximum value, the sum or the total of the values in the list. Let me create a list of numbers, some random numbers, for example 3 1 4 1 5 9. This is a list of items, list of numbers, which includes 6 numbers. Print length of this list. This will get the length. And another one to get the total value of all these numbers. So when we run this, the first line gives us 6 because there are 6 items in the list. There are 6 numbers, 1 2 3 4 5 and 6. The second line gives us the smallest value among these numbers, which is 1. The third one gives us the maximum value, the largest value, which is 9, and the last one gives us the summation or the total value, which is 3 plus 1 plus 4 plus 1 plus 5 plus 9. These are really handy for working with numerical lists. We can also do iterating over lists. For example, most of the time we process lists using loops. Let me create another list like fruits such as apple, plum, and cherry. This is actually what we covered in previous session as well, but I would like to go over it one more time to clarify it. For fruit, in fruits, print I like fruit. Running this prints I like sorry, it should be like this. I like apple, plum, and I like cherry. This is how loops and lists work together. The loop goes through the list one item at a time. We can also take parts of a list using slicing. Let me create another list, slicing lists, a list of numbers like 10, 20, 30, 40, and 50. And let's see how we can use slicing. Print numbers this will give us 20, 30, and 40. Print numbers this will give us 10, 20, and 30. I can also do print numbers and this will show 30, 40, and 50. So let's run this. The first line gives us items from index 1 up to but not including 4. So index 1 is 20 up to but not including index 4, 20, 30, and 40. The second line gives us the first 3, 10, 20, 30, and the last one, this line, gives us everything from index 2 to the end. Slicing is a very powerful way to work with sublists. We can also do nested lists. So lists can even contain other lists. For example, matrix equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Print matrix 0, 1. This is like a table, rows and columns. Here, matrix 0, 1 means go to the first row, then the second item. Let me run this. I need a semicolon here, or a comma, sorry. So after running this, matrix 0 and 1, the first row and the second item, which is 2. So in summary, lists let you store a collection of values. You can create them, access items by index, and modify them. Use append and insert to add items. Use remove, pop, or del to take items out. Built-in functions like len, min, max, and sum make lists easy to analyze. Loops let you process lists item by item. Slicing lets you grab parts of a list. And nested lists allow you more complex data structures like grids. Lists are fundamental in Python, and you will use them in almost every program you write.